Today we're working on 2.6, theoretical and experimental probability. A few things that you need to know before we start today. The probability of an event tells you how likely it is that something will occur. An outcome is the result of a single trial. For example, if you roll the dice, the outcome, like if the dice landed on a 3, that would be the outcome. The outcome would be 3. Sample space would be all your possible outcomes. So rolling the dice again, your possible outcomes could be 6, 5, 4, 3, 2, or 1. And an event is any outcome or group of outcomes. Alright, let's go into theoretical probability. Theoretical probability is the number of favorable outcomes over the number of possible outcomes. So this is an equation that we'll use throughout our examples today. Something else, if it's an impossible event, sometimes the word number 0 is used, where a certain event or something that will happen for 100% sure, that would be 1. For example, like, what is the chance of rolling a 1, 2, 3, 4, 5, or 6 on a die? There's a 100% or a 1 chance of that happening. So the probability is very certain that would happen. Another vocab complement of an event would be considered, it consists of all the outcomes not in the event. So that would be the complement. We have one more piece here, odds, and another equation. So odds describe the likelihood of an event by comparing favorable and unfavorable outcomes. Odds in favor, number favorable outcomes to the number of unfavorable outcomes. So this piece, favor, if they're in favor, then that's what happens on top, to the number of unfavorable outcomes. Or you could just fill it like number of outcomes, favorable outcomes to number of unfavorable outcomes. Where here, odds against, if that wording's used, you're going to use unfavorable outcomes to number of favorable outcomes. Last equation is the experimental probability. This is the number of times an event occurs over the number of times an experiment is done. We're going to jump into some examples as we got quite a few today. Slips of paper, each with a different name of a month on it. To find the theoretical probability that a slip selected random from the bowl has the name of the month that ends with BER. So first thing, number of favorable outcomes over the number of possible outcomes. Okay, we're trying to find the theoretical probability. This is my formula. So I need to figure out how many months there are with BER ending. So kind of go through. January, nope. February, no. March, no. April, no. May, no. June, no. July, no. August, no. September, yes. October, yes. November, yes. December, yes. So there's number of favorable outcomes. So what's the chance of it happening? There's 4 months, which are right here. All over, how many possible? Well, we said there was 12 months in a year to start with. That's how many pieces of paper there were. 4 divided by 12 is 1/3, so that's simplifying. The probability of picking a month that ends with a BER is 1/3. Alright, for example number 2, for a number cube, find the probability of not rolling a number divisible by 3. So obviously 1, 2, 3, 4, 5, and 6 are my possible outcomes. Number of favorable outcomes, so which one of these are divisible by 3? Remember, for divisible by 3, one of the rules is add up the digits to see if they're divisible by 2. So 3 and 6 are my 2 that are divisible by 3. Over my possible number of outcomes, 6 total, so you have 1/3. Now, one piece important here is your equation. So here, you can see the probability of it not being a number divisible by 3, you're going to use subtraction. Okay, 1 minus probability of that event happening. The other way of an event occurring, you can also use, you can add the probability of the event happening with probability of it not happening. Page 94 in your book. If you don't remember this from the previous course, take a look at that. Don't be afraid to look. Take a look at that in your textbook. So, complement formula, like I said, 1 minus the probability of the event happening. So we said 1 minus 1/3, this is the probability of the event happening. So 1 minus that, 1 minus 1/3. It's going to give you 2/3. That's your simplified. So probably not rolling number divisible by 3 is 2/3. Find the odds for the spinner below in favor of the spinner landing on an even number. So let's take a look. The odds in favor of the spinner, so let me be the favorable to the unfavorable. So let's take a look. How many are my favorable outcomes? So it could land on 2, could land on 4, could land on 6, could land on 8. What are the non-favorable outcomes? Are 1, 3, 5, and 7. So how many of each? There are 4 favorable to 4 unfavorable, which simplifies 1 to 1. So instead of using the word 2, you'll probably typically see 2 dots. So 1 to 1 or 4 to 4, which simplifies to 1 to 1. Next example, quality control inspects 500 belts at random. They found no defects in 485 belts. What's the probability that a belt selected at random will pass quality control? Number of times an event occurs over the number of times the experiment is done. So taking a look, how many times does the event occur over the number of times the experiment is done? It just said here 500 belts were selected at random, so that's the number of times we selected a belt to inspect it, and then 485 did not have any, so how many will pass? So 485 pass quality control inspection. This can simplify down. 485 divided by 500 would be a fraction, which is the fraction would give you a decimal 0.97 times it by 100 to get 97%. When you're talking about probability, typically you will write it as a percent. Alright, our last example for today is if the belt manufactured from the problem 4 has 6,258 belts, predict how many belts are likely to have no defects. So this is how many were selected. So we need to figure out how many will not have it. So number of with no defects equals the number of no defects times the number of belts. So we just said there was a 97%. That was the probability of it not having a defect. So you take your 97% and times it by your total number that we're working with now. So 97 times 6,258, you're going to get 6,070.26. What is that telling you? Well, approximately 6,700 belts are likely to be fine. They don't have any defects from your sample of 6,258. That is all for today.